Today we're going to be talking about the graphing of sine and cosine functions. Before we do any graphing though, we need to go over some of the critical vocabulary. Starting with the domain, we know that the domain of a function is all of the input values. In our case though, we are referring to the domain as being the angle values. These are the angles that you're going to be able to find on your unit circle, which we're going to be doing down below. The range refers to the values that you get out of the function, so the output values. In our case, the range values are going to be the actual ratios that, once again, we get off of the unit circle down below. The amplitude is defined as half the distance from the highest to the lowest y values of our graph. I also like to define the amplitude as the distance from the midline, and we'll talk about where the midline can be found, but it's the distance from the midline to the highest or lowest point. So often I will talk about finding the midline. And then finally, the period is the length of the graph before it starts repeating itself. And we're going to see that when we start graphing a couple of these, that it's always going to have some repetition. Now, as we do these graphs, you're always going to be including what we call the critical values. These are the key important points of the graph. Whenever you're graphing one of these functions, you're always going to need to have at least 5 of these critical values along the x-axis for each graph. And we'll talk about what goes along the y-axis as we start looking at a couple of these. So now, the actual graphing of these, we're going to kind of look at this first graph and see where these come from by using the actual unit circle. So we're going to be graphing your initial y equals sine of x. I'm just going to write out the equation here. Y equals sine of x. The x values, remember, these are going to be the angles. So if you look at our table over here, you can see that I've entered in all of these different angle values coming from off the unit circle. The y value is going to be the actual sine of these angles. So the y value is going to be the ratio that we get at each one of these angles on the unit circle. Now, for the sake of being able to plot some of these on our graph, we might want to come back and look at some of these as decimals in a moment. But for the time being, let's just look at what some of these values are. So if I, for example, look at an angle of 0 degrees or 0 radians, and I'm looking for the sine of that angle, I can see that the sine of that angle is still 0. At pi over 6, the sine is 1/2. At pi over 4, the sine is root 2 over 2. Now, root 2 over 2, if I put that in your calculator, that's approximately, we'll put approximately 0.71. So I'm just going to put 0.71 over here. At square root 3, I have a sine value of root 3 over 2. Root 3 over 2 is in the calculator. It's approximately 0.87. So I'll put 0.87 here. And then at pi over 2, we have a sine value of 1. And then we can kind of keep going around the unit circle. So at 2 pi over 3, our sine value is another 0.87. At 3 pi over 4, my sine value is root 2 over 2, which is another 0.71. At 5 pi over 6, my sine is once again 1/2. And at pi, my sine is 0. So these are all my ratio values. Okay, if we keep going around the circle, at 7 pi over 6, my sine is negative 0.5. Oops, negative 0.5. At 5 pi over 4, I have negative 0.71. At 4 pi over 3, I have negative root 3 over 2, which is that negative 0.87. And at 3 pi over 2, I'm at negative 1. Okay, and if we kind of keep going, at let's see, at 5 pi over 3, I'm at negative root 3 over 2, so that's negative 0.87. At 7 pi over 4, I'm at negative 0.71. At 11 pi over 6, I'm at negative 0.5. Whoops, negative 0.5. And at 2 pi, I am back to 0 again. So again, the graphs that we're graphing come directly from the unit circles. All we're doing is looking at each angle, taking the sine of that angle, and the output is the ratio that we get at the sine of that angle. Now, if we graph these points, we can kind of see what these sine graphs are going to look like. If you look first of all at your y values, you'll notice that your highest y value appears to be this positive 1, and your lowest y value is this negative 1. So on my y-axis, I'm going to mark a positive 1 and a negative 1, and everything else falls in between them, okay? Then the actual graph, at an x value of 0, my y stays at 0, so I'm basically plotting this point 0, 0. Then at pi over 6, I am at 1/2. So if I kind of estimate about halfway up. Then at pi over 4, I am at about 0.71. At pi over 3, I'm a little higher. At pi over 2, I've reached my highest point of 1. And then you'll notice that I start just making my way back down. 0.87, 0.71, 1/2 again, and then at pi, I am back at 0. Okay, then as we keep going, at 7 pi over 6, we're down here at negative 1/2, negative 0.71, negative 0.87, and I reach my lowest point of negative 1. And then I continue back to negative 0.87, negative 0.71, negative 1/2, and at 2 pi, I'm back at 0 again. Now, if I was to continue, remember that once I made this one complete circuit, I just went around this unit circle one time. So if I was to continue going around this unit circle, we're going to see that I'm just going to get the same values over and over and over and over again. So essentially, the graph is just going to repeat the same pattern that we've just seen here. This, what I've graphed right here, guys, I'm going to mark this in green, this is what we call the period of one function. Okay, so this right here is representing my period, because after that, I just start repeating that same graph again. So now, some of those key information from above. The domain of this graph, remember, represents all of the angles that you could enter into the function. Okay, we could keep going around this unit circle over and over and over again. So the domain is going to be all real numbers, or you could say negative infinity to infinity. My range, however, is limited. You'll notice that my highest and lowest y values were from negative 1 to 1, so my range is from negative 1 to 1. I don't go anything beyond that. Again, back to the unit circle. Remember, the unit circle has a radius of 1, which is why this happens. The amplitude is the distance from, or is half the distance from the highest to lowest point. Well, from negative 1 to 1, is a distance of 2, and if you take half that distance, we're saying that the amplitude is 1. Another way to look at it is to say, where's the midline? The midline is kind of this line, this horizontal line that goes right smack through the middle of the graph, so I call that the midline. And you'll notice that from the midline to the highest point is 1 unit, and from the midline to the lowest point is 1 unit as well. The period is the length of one cycle. So we went from 0 to 2 pi, which means that the length of this one cycle is 2 pi units long. Now, as we start looking at the graphing of these, many of these values will start to change as we start changing things in the function. But this is what the general graph looks like. So now for a cosine graph. Cosine graphs, guys, are going to work very much the same way. And in fact, we may not necessarily plot every single point here. But in terms of where the graph actually comes from, if you take all of these different x values, or these angles, and find their, oops, this is supposed to say cosine, I'm sorry, and find their cosine values over there on the unit circle, we can plot a few different points here. So for example, at 0, my cosine is 1, so I'll start with a 1 here. I'm just going to jump around a little bit. At pi over 4, my cosine is root 2 over 2. Now remember, root 2 over 2 was approximately 0.71. Okay, at pi over 2, my cosine is 0, so now I'm back to 0. At 2 pi over, let's jump to 3 pi over 4. At 3 pi over 4, my cosine is negative 0.7. Or negative 0.71. At pi, my cosine is negative 1. Okay, at 5 pi over 4, my cosine is negative root 2 over 2, so that's going to be negative 0.71. At 3 pi over 2, my cosine is back to 0 again. And at 7 pi over 4, my cosine is root 2 over 2. That's, that's positive 0.71. And then at 2 pi, my cosine is back to 1 again. So if we look at how we would graph this on my graph here, we can see that once again, my highest and lowest y values are 1 and -1. So I'm going to start with a 1 and a -1 on my graph. We can see that at my first ordered pair, so at an x value, an angle of 0, my y value is actually 1 this time. So we're actually starting up here. And again, if we plot a few of these other points, at pi over 4, I'm at about 7.71, so I don't know, it's about halfway around here. At pi over 2, I'm at 0. At 3 pi over 4, I'm at about -0.7. At pi, I'm at -1. At 5 pi over 4, I am at about -0.7. At 3 pi over 2, I am back at 0 again. At 7 pi over 4, I'm at +0.7. And at 2 pi, I am back to 1. And again, if I continued going around the unit circle, I would end up seeing the same thing happen, where I would go down and I would turn and start coming back up, and it would just keep going. So my period is going to be from right here to right here. After that, it starts repeating itself again. This is our basic cosine graph. Now, once again, in terms of the main functions here, the domain of this graph, again, this could be all angles. I can keep going around that unit circle hundreds of times. So my domain is still all real numbers. My range still goes from -1 to +1. My amplitude, remember, that's the distance from, I like to say it's the distance from the midline to the highest point and to the lowest point. We can see that that distance is 1 again. And then the period, again, goes from my 0 to 2 pi. So my period is once again 2 pi. So as we graph these functions, the two that we just saw are what we call the parent graphs. And all of these functions, sines and cosines, are going to have these same general shapes. But as we start adding in other values, we're going to start seeing that some things do change. So we'll start with looking at a vertical stretch. Now remember that this is a sine graph. Okay, with a sine graph, we know that, if you think back to that parent graph, we know that a sine graph is always going to start at the center. It's going to go up first, come back to the center, it's going to go down, and then it's going to come back to the center again, and that's where the one period stops. I mentioned before the 5 critical values. The 5 critical values that we always want to graph on a sine function are going to be these 3, what I call midline points, as well as your highest and your lowest points. So on your graph, on your unit circle, what we're looking at are these 5 points right here as our critical values. So thinking back to the original sine function, at 0 we were at 0, at pi over 2 we were at 1, at pi we were back at 0, at 3 pi over 2 we were at -1, and at 2 pi we were at 0. So there's my basic general sine graph. Okay, we know that this graph has a domain of all real numbers, a range of -1 to 1, an amplitude of 1, and a period of 2 pi. But now we start adjusting that. Okay, so now let's say that we took 8 times the sine of x. I'm going to zoom in just a little bit here. So what that means is I'm going to take all of these y values, all of these ratios from before, and I'm going to be multiplying each one of them by 8. Okay, for example, right here, if I take 8 times the sine of x, well, the sine of x was 0. 8 times 0 is 0. Okay, in pi over 2, we're going to do 8 times the sine of pi over 2, which was 1. 8 times 1 is 8. Okay, the next one, we're going to do 8 times the sine of pi. Sine of pi was 0, so that's still 0 again. 8 times the sine of 3 pi over 2, that was -1. So that's going to give us a -8. and then 8 times 2 pi, the sine of 2 pi. The sine of 2 pi was 0, so we're right back to 0 again. So think about what's actually happening on this graph here. If I was to plot these different points, so now at an x value of 0, my y value stays at 0. I'm going to start by plotting that point. I'm also going to take just a quick moment and actually label my x-axis with all of my critical values. So we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to look for my highest and lowest my highest and lowest y values. Now you can see it changes here. My highest y value is now 8. My lowest y value is now -8. So on my graph, I'm going to go up to 8 and down to -8. You do not need to mark everything in between. We just need to have those highest and lowest values. And now I can start plotting these points. Again, I've already plotted that first point. Now at pi over 2, I'm up at 8. So I'm going to go all the way up to my highest point. At pi, I'm at 0, so I'm going to come back to 0. At 3 pi over 2, I'm at -8, so I'm going to go down to my lowest point. And at 2 pi, I'm back at 0. You'll notice that the sine function itself, the shape, did not change. Okay, the one thing that changed here is the range. Okay, my range is no longer -1 to 1. Now my range is -8 to 8. And also the amplitude. The distance from, here's that midline right down the middle, the distance from that midline to the highest point is a distance of 8 now. The domain has not changed. It's still all real numbers. My period still goes from 0 to 2 pi, so my period is still 2 pi. So the only thing changing here are the range and the amplitude. Now notice if you see the connection to the equation, the amplitude is actually the 8 that's located in the equation. That's also telling me what my range is going to be, since I know that I'm going from the midline up and down that amount. So we can use it as a shortcut when we're graphing one of this next problem here. Okay, we know again the general function, and we know the general sine values go from 0, 1, 0, -1, 0. Now all we're doing is multiplying all of those values. Those are my sine values. We're multiplying all of those values by 1/2. So the 0 stays 0. The 1 becomes 0.5. 0 times 1/2 is still 0. -1 times 0.5 is -0.5. And 0 times 0.5 stays 0. When I graph this, we can see that my highest y value is 0.5 and my lowest is -0.5. So I'm going to go to +0.5 and -0.5. You always want to label your x-axis, so I'm going to plot my 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I can plot these points. At 0, I stay at 0. At pi over 2, I go up to 0.5, down to pi, down to -0.5, and back up to 0 again. Okay, and again, once again, my domain is all real numbers. My range has now changed from -0.5 to +0.5. My amplitude is 0.5, and my period remains 2 pi. Okay, so let's talk about trying to graph a couple of these. And again, we want to really focus on how we can apply some of what we already know to these graphs. We have a combination here of sine and cosine graphs. So one thing I always say to do at the start is to pay attention to which function you're looking at and make sure you understand the shape of that function. My cosine graph, for example, we know a cosine graph is the graph that starts at 1, goes down to the midline, down to the lowest point, back to the midline, and ends at 1. My sine graph, however, this one, a sine graph will always start at the midline, go up to the highest point, back to the midline, down to the lowest point, back to the midline. So I tend to start by looking at each one and recognizing what shape this should look like. Okay, then we can look at this A value. Okay, we're going to refer to this as the A value. And remember that the A value is actually going to end up telling me my amplitude. Okay, in this case, what this means is that from my midline to my highest point is going to be 5 units. So my amplitude is 5. That's also telling me my range. I'm going to be going down to -5 and then up to +5, giving me a range of -5 to 5. And again, I can plot those on my graph right away. Okay, for right now, we haven't changed any of our critical values, so we're still going to use the same critical values here of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Yes, it does start to get redundant to write those each time, but eventually those values do change. And again, we know the pattern. So because we already know the pattern, we can actually graph this right away. We know that this graph, this cosine graph, should be starting at the highest point, which is 5. It should go to the middle point, down to the lowest point, -5, back to the middle, and back to the highest point. There is my cosine graph. The domain is all real numbers, and the period remains 2 pi. Okay, and we can kind of graph that for some of these different ones as well. If we look at this sine function, okay, now the sine function, we can see that we know what the shape is supposed to be. We know that the A value here, the amplitude, is -4. Now keep in mind, guys, that by definition, the amplitude is a distance. And a distance is never negative. A distance is always positive. So even though we're seeing a negative there, I'm still going to say that my amplitude is 4. And what does that mean? That means that from the midline, I'm going to go down 4 and up 4, which means that my range will be from -4 to 4 again. My domain is still going to be all real numbers. My period is still going to be 2 pi. And right away, I can at least plot what I know, which is my y values of +4, -4. And I know my x-axis of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then I can plot these points. Now, keep in mind that based on the fact that I am using this -4, if we actually went back to the original sine points, remember that when we plugged in these different x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember that the sine values from the unit circle were 0, 1, 0, -1, and 0. And we're going to be multiplying each one of those by a -4. So we're going to be multiplying -4 times each of these values. Well, here's going to be the one new change that happens here. When I multiply a 0 times -4, I still get 0. 1 times -4 gives me -4. 0 times -4 is still 0. -1 times -4 is 4. And 0 times -4 is still 0. So what changed? If you plot these points, at 0, I'm still at 0. But at pi over 2, you'll notice that I'm down at -4. Then I'm back at 0. Then at 3 pi over 2, I'm up at +4, and then at 2 pi, I'm back at 0. So what happened here is that my sine graph actually flipped over. Anytime you find that your A value is negative, that's going to cause the graph to flip. So that's, again, another little shortcut that we can watch for when we're graphing these. Okay, so let's take a look at this example here. We've got a cosine. Okay, we know that the cosine graph, again, I always like to kind of start out over here saying cosine graph starts at my high point, goes to my midpoint, down to my low point, midpoint, high point. There's my cosine graph. This cosine graph has an A value of -3/4. So that tells me that the amplitude is 3/4, that the range is going to go from -3/4 to +3/4. I'm going to put both of those on my graph right away, +3/4, -3/4. My x values are still 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now when I go to plot these points, remember the shortcut that we just learned. Because that's negative, we know that this graph is going to flip, which means instead of starting at my highest point, I'm actually going to start down here at my lowest point. Then the middle, then my highest point, back to the middle, back to my lowest point. So it's a flipped cosine graph looking like this. Now keep in mind the period is still 2 pi, the domain is still all real numbers. Okay, final example here, we're back to another sine graph. You'll notice that the a value is a positive 2/3. That's my amplitude as well as my range. And again, I can put both of those on my graph right away. My critical values, 0, pi over 2, pi, whoops, like that pi, 3 pi over 2, and 2 pi. Since there is no negative, there is no flip, which means that we will do our traditional sine graph. Traditional sine graph starts at the center, goes up first to the highest, back to the center, down to the lowest, back to the center, and there's my sine graph. Period is 2 pi, domain is, again, all real numbers. So in summary, all that we've looked at here today is what we call a vertical stretch. Okay, this a value acts as what we call the amplitude, but it's also referred to as a vertical stretch because you can see that it's stretching the graph out or it's shrinking it down. So sometimes we call this a stretch or a shrink. What we've seen here is that if the a value, now take a look at a few of these, okay? If the a value is more than 1, so example 1 here where the a value was 5, for example, that's going to stretch it out. That's going to make it 5 times larger. So this is an actual stretch, and it's going to make it, I don't know, taller, I guess. If the a value is between 0 and 1, like in example 4, 2/3, that's actually going to shrink it because it's kind of squishing the values together, making them 2/3 as tall. If the a value is less than 0 or negative, that is going to flip the graph. So you need to know that parent shape, and then you're going to be flipping that parent shape over. As we kind of add on each day and look at some more different types of what we call transformations to these graphs, we're going to start seeing how more and more things will start changing. But for today, we're just going to focus on that vertical stretch and understanding the main shape of each of the graphs before we add on too much more.